Hello, let's start with the bioenergetics now. So bioenergetics means it's the study of energy changes in the biochemical reactions. There are two systems, non-biological system and biological systems. We belong to the biological systems. Non-biological system use heat energy, whereas to power up our living process, we use a chemical energy. If this is a reaction, A plus B forms C plus D. Only the initial stages and the final stages are described by the bioenergetics, not the mechanism with which the reaction process takes place. The bioenergetics reveals whether the process is possible or not, but the kinetics represents whether the reactions proceeds in a faster manner or not. So it only predicts whether the reaction is possible or not. So the importance of bioenergetics is, this is nutrition. So the food we take, which undergoes a process called metabolism. This is where the chemical reactions takes place and gives the energy for our living. So the bioenergetics is very important to know how the nutrition we are taking is converted to energy. So then, if our energy fuels are depleted due to starvation or fasting, it leads to death. Energy is depleted here. In the middle picture, during energy imbalance, it will lead to malnutrition. So, anything which related to energy, it causes some disease or disorders. Whenever the energy we are giving to our body is surplus, is excess in amount, it leads to obesity. These are the importance of energy fuels. So what is a free energy? Free energy means it is a useful energy in a system. It is represented by delta G. Gibbs change in free energy is that portion of the total energy change in a system that is available for doing work. So free energy means useful energy. Gibbs change in free energy means whatever useful energy we are taking in is available for doing work. This is also known as, the Gibbs free energy change is also known as chemical potential. So it is explained by two laws of thermodynamics. The first law of thermodynamics states that total energy of a system, including its surroundings, remains constant. That means energy is neither lost or gained during any change within the system. So total energy of the system remains constant because the energy is neither lost nor gained. So in living system, chemical energy may be transformed into heat energy, otherwise into electrical, radiant or mechanical energy. Now what is the second law of thermodynamics? The total entropy of a system must increase if a process is to occur spontaneously. Entropy means, what is this entropy? It means extent of disorder or a randomness of the system, and it becomes maximum as equilibrium is approached. So whenever the extent of disorder or randomness of the system to occur, the total entropy of a system must increase. The randomness and the disorder should increase if a process is to occur spontaneously. So if you take a balloon here, it is tied here. But when there is a small hole in the balloon, the air from inside the balloon moves out. This is a spontaneous process. Whereas the reverse process is not spontaneous. You cannot move the air inside the small hole into the balloon. This reverse process is an impossible one. So, which is the spontaneous process? The air moving from the balloon to the environment. So, for the spontaneous process to occur, the total entropy of a system should increase. So, under conditions of constant temperature and pressure, we combine the first law and the second law. So, the relationship between delta G, free energy change of a reacting system. This is explained in the first law of thermodynamics. Entropy, change in entropy. This is explained in the second law of thermodynamics. So, combining these two, we get this reaction delta G is equal to delta H minus T delta S. This is under condition of constant temperature and pressure. Delta H is the change in enthalpy. Enthalpy represents heat. T is the absolute temperature.